Good everyone, my name is Graphics. Today we want to solve another problem involving Thevenin theorem, where we are going to be analyzing the circuit that is displayed in the front of your screen. Now, if you look at the circuit closely, we have two current source, which is 5 ampere and 2 ampere, and we have three resistors that has resistances of 0.5, 0.1, 0.4, and we are told to calculate for the current that is flowing through the load 0.1 ohm resistor, right? Now, one thing you need to know first of all, you need to recall that for me to calculate the current flowing through the load, because resistor, like I said, is in form of a load, is giving us the I subscript L, that means the current that is flowing through the L, which is the load, and the load is the resistor that we are considering, equals to the Thevenin voltage all over the Thevenin resistance plus the RL, that means the resistance of the resistor that we are considering, which is what? 0.1. Now, in our previous video, we discussed a circuit that has two voltage source in which we sought for the load flowing through the given resistor that we're considering. So if you want to know more about that, you should click on this link at the top right corner of the screen to give you more understanding, and on that video you will learn what the theorem states. Now, this formula here is the theorem in short, right? This is what the theorem is telling us about. So the first thing first of all do is to calculate for the Thevenin voltage. If you like, you can start from calculating for the Thevenin resistance, but I love calculating from what? For the Thevenin voltage. Now, in calculating for Thevenin voltage, we have to remove the load that we are considering, the resistor that we are considering, and which is what? 0.1 ohm. So I'm going to remove the 0.1 ohm, the resistor there, I'll replace with what? My VTH, which will be something like this, right? Now, what do you notice? The VTH, there are two terminals because I've already removed that circuit. So that place is now open, right? So it's open now, having two terminals, point P, point Q, right? So the Thevenin voltage will be the potential difference between those two terminals. That is what we're actually looking for. Now, in doing that, let's start. Let me name my loop. Let's say this point here is A, this is B, this is C, D, E, F, G, H, right? That is my loop. Now, I want to consider a particular section of this loop, which is what? We'll consider loop A, B, G, H, A. So this is what we have in here, right? So this is the loop that we just considered. Now we'll name that loop to be I1, right? So it means that I1 will be flowing clockwise in this manner, right? Now the good news here is I1 is already given, so we don't have to calculate for I1 just like we did in our previous video. So our I1 is given as what? 5 ampere, because this is the current source here. So we already know the amount of current that is flowing. Current that is flowing is what? 5 ampere. So let's apply our Ohm's law that says that what? V is equals to what? IR. Now the V we are looking here is the voltage drop. And the voltage drop here is as a result of what? 0.5 ohm. So I write V is equals to 0.5 ohm equals to I is the current that is flowing through that resistance, that's flowing through the resistance, the resistor, which is what? 5 times the arrow there is the resistor itself, the resistance of the resistor that we're considering, that we are looking at here, which is 0.5. So 5 times 0.5, that will give us 2.5 volts. So we've gotten the voltage drop across 0.5 ohm resistor. Now we'll now consider the other loop, which is loop CDEFC, which is what we have here. Now, if you look at this dependent current source 2A, look at the arrow is facing up. So we are taking the direction of the arrow, which is, we call that loop, that circuit there, I2. So it means that I2 is flowing in this manner, right? Now the good news is we have I2 already. I2 is giving us what? 2 ampere. So 2 ampere is one that is flowing through this circuit here that we're considering. So we will now calculate for applying our Ohm's law. We say that my V as a result of the 0.5 ohm, that means the voltage drop as a result of what? 0.5 ohm, we call it V subscript 0.4 ohm, right? Is equals to I is the current that is flowing through, which is your 2, multiplied by arrow is the resistor through which the current is flowing, which is what? 0.4. So my V subscript 0.4 is equals to what? 0.8 volts. So we've gotten the voltage drop as a result of what? The 0.4 ohm. So we've gotten this. Now we'll now consider the loop BCFGB, which is this. And you realize this is our what? Our VTH. Now we know very well that this is 0.5, 0.4. Now we are going to be applying the KVL, Kirchhoff voltage law here. Why are we calculating it? Because we already know the voltage that is flowing in this line, right? In this part, BG. So the voltage flowing here as a result of the current that is flowing, we say that our V 0.5 is given as what? 2.5. So the voltage flowing here is what? 2.5 volts. While the voltage flowing along CF is given as what? 0.8 volts, right? That is the voltage flow we calculated. This is where I calculate for Thevenin voltage. So if we apply, that means the voltage at each of this terminal here is, at this point here, will be what? 2.5. At this point here will be what? 0.8. So the voltage difference, the Thevenin voltage will be the voltage difference. So my Thevenin voltage, VTH, will now be 2.5, or will now be V subscript 0.5 ohm minus V subscript 0.4 ohm. And V subscript 0.5 ohm, which is the voltage across 0.5 ohm, is given as 2.5, and the voltage across the 0.4 ohm is given as 0.8. So if you subtract them, my V Thevenin will now be what? 1.7 volts. Is that okay? Now after that, we've gotten our V Thevenin. The next thing we'll now do is to calculate for the arrow Thevenin. So calculate for the arrow Thevenin, we are going to open circuit the two current source. If it was a voltage that was there, we are going to short circuit it, replace the wire, but now we're going to open circuit it. So we're going to remove it from there. So removing it, we will now replace the VTH by the ROTH, right? So in doing that, as we have removed the 2 ohm and the 5 ohm, it means that current cannot flow along that path anymore. So I can likewise remove CDEF this way and remove ABGH this way, right? So I'm left with this. So we want to know the ROTH. So if you look at this now, my ROTH means that the 5 and 0.5 and 0.4 are in series because the same current that will be flowing through them, right? So we'll say that my ROTH will now be 0.5 plus 0.4. Is that okay? So the 0.5 plus 0.4 will now give us what? 0.5 plus 0.4 will now give us 0.9, right? So we've gotten ROTH and we've gotten the VTH and we know our ROL. So we now put them into the equation above, the formula we wrote earlier, which is IL equals to what? VTH all over ROTH plus RL. So this will now be equals to, what is the VTH? VTH is what? 1.7 divided by the ROTH we calculated for is what? 0.9 plus the RL, which is the resistor that we are considering, which is given as what? 0.1. So this will now give us my IL, which is I'm saying I as a result of what? The 0.1, right, is equals to 1.7 all over 1.0. And 1.7 divided by 1.0 is going to be giving us 1.7 ampere, right? So the load that is flowing through the 0.1 ohm is 1.7 ampere, and that is all. So you can see it is easier as we climb up the ladder. So when you have current source, the circuit tends to be more easier than when you have a voltage source. So if you found this video helpful, please don't forget to click on the subscribe button. Thanks for watching.